a lot of different things going on in the fuser area to help diagnose whether or not you are running into any kind of contamination issues that are related to your substrate settings. What I want to do is start with talking about, even though these top things where we've got the IQ diagnostics, machine codes, print quality issues, obviously those are all things you're already well aware of. But what we want to do is concentrate. I want to spend a few minutes talking specifically about what's going on in the fuser area when you're doing your daily and you're opening it up and look at exactly what you're up against. So when you're doing your daily and you take a look at your fuser area, looking at your donor roller, your metering roller, a couple of quick warning signs to alert you that you may have some things going on is the donor roller itself and the metering roller. So are you seeing dry ink on the donor roller? Not stains after a period of time where it starts to discolor, because it's going to do that even if you keep it clean. I'm really talking about where you can really see the dry ink on the roller. Same thing with the metering roller. Are you seeing lines of dry ink on that metering roller? There's a couple of things going on that could be causing that, but one of the things that could be causing that are our temperature settings. I also encourage people to pay really close attention to their fuser cleaner web. If you're occasionally open that up and look at your fuser cleaner web and see whether you're getting a lot of dry ink all over that roller. If you are, then that's another sign that you are having some hot offset issues, and those are things that we want to try to control, because that is what's contaminating your fuser oil. It's getting through the whole system, and it's really making it harder for you to keep everything clean, and it's making it harder for you to keep your quality where you want it to be. So by looking right at your fuser area, looking at that, a couple of things right away, which I like to tell people is a good way to test and see whether or not you are having overall some contamination issues due to hot offset, would be looking at your fuser oil reservoir. You really want to strive for that fuser oil to be a light gray, maybe a little bit of a tint to it. And the darker it is, when you start looking at dark red, dark blue, purple, brown, that is really where it's saying to us, okay, we may want to look at some things and address some things, but first, the most important thing is diagnosing it, because we want to make sure that we are diagnosing that we are having, whether we're having a hot offset issue or whether we're having a cold offset issue. A lot of times with cold offset, it's pretty simple, because you're going to know, because you're going to see it on the sheet. You're going to see that the ink is scratching off. It may be scratching. It may be bubbling. It may not be laying right. That is a little more of a red flag that you're going to see and say right away something's wrong. The hot offset may not be giving you the kind of alert you think you should be getting, because you're using settings that are either already in the system or on qualified substrates, and you don't realize that that could be causing you some potential issues. So that's why I tell people to keep an eye on that oil, and if you are falling into the category of that oil being really dark, then we want to start to try to address that. We also want to look at that fuser cleaner web and see whether we're getting a lot of dry ink on that. Now, if you are a shop that's running a lot more uncoated than coated, it's harder for you to keep that whole system perfectly clean. Even if we get the temperatures and the substrates exactly perfect where they need to be, you're still going to get a little more hot offset than you would with the coated sheet. We're not going to eliminate contamination. All we want to do is try to minimize it as much as possible, and when it's in our control and we can minimize it, that's what we're striving for. You're never really going to see that your fuser cleaner web is perfectly clean, but you want to start to shoot for that. So I'm going to move to the next slide and basically talking about exactly what I just said, which is where our dry ink would build up. So looking at the fuser cleaner web, examining it real well, seeing whether or not we're seeing long, if you're seeing black stripes going across, one of the things that I suggest doing, because now we have to narrow it down, excuse me, we want to try to figure out whether one stock or multiple stocks or all your stocks are doing this. So what I usually tell people to do is to open up the fuser, advance your cleaner web till it's 2 or 3 turns till it's perfectly clear. Then start with your most common stock, the sheet you're running the most, more than anything else, and run about 200 sheets of a job that's got moderate to heavy coverage. Doesn't have to be solid ink coverage, a couple of photos on there, just more than just a little bit of text. So we've got something to really gauge it by, and run about 200 sheets. Then open up the fuser and open up and take a look at that fuser cleaner web and see how it looks. If you see a little bit of color on there, you're probably fine and probably don't really need to do anything about it, although you can go in and we can talk about fine adjusting that. If you're seeing a lot, a pretty good amount, and sometimes it may take longer than 200 sheets, but 200 sheets is a pretty good starting point because you'll start to see whether or not it's a big issue, and there are certain times when you'll see this a lot more than others, especially if you're using the matte roller. And if you use the matte roller quite often, you will see that that contamination is very difficult to keep under control. So we can talk a little bit about, when we get to that, talk a little bit about some things that can be done to help keep that under control when you are using the matte roller. But right now, I just want to talk about our diagnosing what's going on and diagnosing that we do have to make an adjustment. So pick 3 or 4 of your most common stocks, the ones you really use the most of, and do this test. Then advance the fuser cleaner web, close it, try another one. This way you can put a little check mark next to it or put a little X next to it saying, I think I need to look at this one a little bit closer. Diagnosing is the first step. After we've diagnosed that we may have temperature that may be too hot, which I have found that a lot of the substrates, a lot of the shops that I have been to personally and a lot of people that I've talked to are running too hot. And we want to make those adjustments because not only are they causing a contamination, but they're also could be potentially causing you some jamming issues, some wrap-ups. They could be causing some unnecessary curl, and they could be also causing some dog earring. There's a lot of little things that could be caused just by these temperatures being too hot, especially in your lighter weight sheets. So going through that, I'm going to kind of hand this over to Ricky now and let him discuss some other ideas on the diagnostics and things you can see right in the system on other ways that you can really diagnose and test this, and then go forward with some ways that we can start to help you determine how to correct what you've got going on. And Ricky, I'm going to turn it over to you.
Thank you, Mike. One thing I just want to add to what Mike has already said, there are some factors that's going to determine whether or not you're running too hot or if you're pulling ink off the sheet to your fuser roller and it's getting down in your system. One is the fuser roller lamp that you're using in your machine. So you pretty much want to make sure you stay with the lamp that was shipped with your product. 2, the fuser roller type. We have a lot of customers that are using what we call the common fuser roller, which is a red fuser roller. Then we have some customers that have been dealing with fuser wrap issues that are using the black fuser roller. If these rollers are in your machine, they need to be set up appropriately so you have the right fusing algorithm to do your calculation for your temperature control. One other element you want to keep your eye on is Mike mentioned items in your fuser sump assembly. This includes your donor roller, metering roller, your blade, and your fuser fluid pad. If your donor roller is not making good contact to the fuser roller surface, that can cause a lack of fluid to be laid down to the fuser roller, which is used as a insulator to prevent that toner from sticking. If you got dry spots where you're putting no fluid on the roller, that area of toner that contacts that roller will stick there automatically. So you're going to want to make sure, number one, you got enough fluid in your fuser fluid sump. And the amount of fluid that's in that sump should be filled up to the level where it drains back appropriately, keeping the right amount of fluid so you don't starve your roller for fluid. Okay, so if all those things are, one other thing I want to add too is a calibration, which your field engineer does for you. So if this is your first time going through these adjustments, you may want to consider having your FE to help you out, making sure that all these things are set up correctly and done properly before you start to make your adjustments. Temperature control calibrations, which is an item that the FE does for you. He will come in with an instrumentation, he will actually measure the fuser roller surface, and he will calibrate your system to operate at a certain calibration factor, which drives how much power your lamp is going to put out of your system. If all these things are okay, then it's good to start your diagnostics. So looking at this slide that's before you now, this shows some image quality diagnostics. So in this case, if you go to Nexpert and you click the wrench and you go to sensory, you'll find a diagnostics that's the first one in the list, and it's called excessive drying contamination in the fuser. And if you, by any means, lose track of how to do this, these steps will walk you directly through to what you need to do as an operator level. Then it will walk the FE through what he needs to do as an FE level to ensure we got proper fusing. So this is the entry page that takes you into the diagnostic. Mike, I think you have control, so if you could go to the next slide. Okay, so you can see in this list, your first line item there is the drying contamination in the fuser. And then, of course, we have two categories here. We have a field engineer diagnostics, and then there's an operator diagnostics. If you click on the operator diagnostics, you can see in the lower right-hand corner of the screen, it'll pretty much bring you to a table that you would use to set your substrates if you're getting excessive contamination by following Mike's recommendations. The first thing you would do, you would run your 200 prints for your problem substrates. And from my experience, I see this more often with uncoated substrates, some matte-coated substrates, and some textured substrates can cause this hot offset to occur at a higher rate. When that happens, we give you a table here that will allow you to set up your substrate settings based upon your substrate GSM value. And this is a good starting point in order to start your system out, and then you will repeat Mike's procedure, run that 200 prints with these new settings. After the 200 prints are finished, you will lift up the cleaning web. You will look at the density of that web, and if that density is real dark, because that dark density in that web will actually cause residual to be placed down on the prints that are coming one after another. So you want to make sure you have minimized that density. So these set points that's in that table is a good place to start with those particular substrate types. Okay, Mike, the next slide. Okay, here is a larger view of that same table. If you just take, for instance, a substrate that has a basis weight or GSM value of 70 to 85 GSM, the set points we would start at would be 143. If you're seeing contamination, we have the NIP at 18,900 and an energy flow at 1,250 watts. What we're doing here, if you look in your substrate assistant, you'll see where those values for the surface temperature, the NIP settings, and the energy flow are different. And in cases with some uncoated stocks, substrates that are not qualified, you'll find that you may have to tweak these settings. So what we're recommending, if you see a lot of contamination in that fuser, start out with the values that's in this table and then start running your sheets based upon those settings. If you still see heavy contamination after using these set points, you still want to reduce your set points even further. And we use a rule, basically we call the 330 rule. And then that means we reduce our temperature by 3 degrees Celsius, and we decrease our substrate energy flow by 30 watts. So for every 1 degree change in temperature, we're changing our energy flow by 10 watts. And then you would adjust that. In this case, say if you started out with just 143, you ran 200 prints, and you still saw you were getting real heavy contamination on your cleaning web. You're seeing residual toner being put on your sheets. Then you would take that down to 140 degrees. You would leave your nip the same, and you would decrease your energy flow by 30 watts, which would end up being 1,230. Then you would repeat that process of running those prints, and when you get a satisfactory density on your web cleaner, now you know you're in a safe zone to run your prints without any contamination. One other thing this does for you too, when you have the proper settings for your fuser, it can also help with your fuser roller life. Because if you're pulling a lot of toner to the cleaning web, you're creating these heavy toner spots called agglomerates. So now you have this toner sitting in that cleaning web, and of course you know that cleaning web engages to the fuser roller surface. So you have this hard toner that's basically just riding on the surface of that fuser roller, which is a smooth, glossy roller. So if that toner rides on that surface, it can permanently damage that roller by having too much excess toner being clinging to that web. So using these set points and these techniques will definitely aid in that. Continue, Mike, to the next slide. Okay, using this diagnostic, what we actually have you do, we have a job set up in an embedded job ticket right in the Nexpert system. You would just load that file, and actually it would print this image that you see on the target to the right. You would take that target and you would take a penny, right, and do a scratch test on that image, and all of this is explained and give you direct detail in Nexpert. You scratch this ink that's on that sheet to, number one, make sure that your adhesion is good, because you don't want to be underfused, because now you send the prints out and you can have jobs returned because your fusing is not adequate. So you want to make sure, number one, you have good adhesion. And it asks you a couple of questions based upon how the ink scratches off. If it tells you that the ink is hard to come off and you're seeing this contamination, it leads you into a link that's called hot offset. And I don't know if this particular diagnostics or the pages we have here go further into detail into this, but it'll actually have you print out an image of, that have different density levels, and you compare the density that's in your cleaning web to the density that's on the sheet. And if your density on the cleaning web is darker than the density that's on the sheet, then we have you make adjustments until we get a density that's acceptable. Mike, do we have another page here?
Just the two questions.
Okay, go back. But as you go through this diagnostic, you will see it'll lead you through step-by-step things that you will need to do to adjust for your contamination that you may be getting in your system. So and then once you go through this a couple of times, right, you become an expert, and like Mike is at this point, and then you won't have to print these prints. You can just actually look at your image, make these quick setting changes, and then go forth to ensure that you're going to get the best quality coming out of your fuser, less contamination, and higher fuser roller life yields.
And I do want to make one comment regarding while you're doing this. One of the things Ricky mentioned about the fuser oil reservoir, making sure that you're not running dry. But what I usually tell people to do, and I think it's important. You're opening that area up every day anyway. You're doing the daily. Keep an eye on that area, that reservoir, but what I suggest doing is allowing that to bleed down to about an inch before the bottom and then filling it all the way back up to the line rather than continually topping it off every morning. This will give you this will get you faster if you are solving the problem and starting to run cleaner. You will notice this faster because as you're allowing that oil to go down and then you're filling it back up, you're not constantly just topping off that dirty oil. So that is a recommendation, but you really still need to make sure that you're keeping an eye on that area and that you have adequate oil and that you're not really going down more than an inch from the bottom. And if Ricky wants to comment on that, please, Ricky, by all means. But that's one thing that I do now, especially now that I've got this completely under control. I'm running a milky white oil, maybe a little bit of a gray tint. I let it bleed down to about an inch from the bottom, and then I fill it back up again, and it works very well. That was the one comment I did want to make about the oil.
Yeah, that's a good point, Mike. Good instructions there. So we do have a sensory in the fuser fluid reservoir. It'll give you a warning first when your fluid starts to get low. That should put you to that area or a little bit below where Mike is describing. But you could put it in, but it will warn you, say, add fluid, and then that way you'll know your system is cleaning up properly and you can manage it. And as he stated, when you do your daily, you take your metering roller out, your donor roller, and you do your cleaning. Peek down inside the sump and just make sure you have fluid inside that fuser fluid sump that's at the drain back spout. You see there's a hole that's on the back side that really opens up to allow the fluid to return back into this reservoir that Mike is speaking of. And if that fluid for any reason is getting low or below that level, at that point it indicates that you got a problem with your pump. So at that point an FE will have to come out and check that for you to make sure you're getting the right amount of fluid, because we pump the fluid into the reservoir at a rate that should keep it at a level without causing it to run dry. If for any reason you're seeing that dry, get your FE in there ASAP and have them fix that for you.
Something that can cause that I've seen several operators do that I kind of, I'm going to, since this is a perfect segue for me to bring this up, is that when you do pull your fuser sump out to do your fuser sump maintenance, so let's say you're replacing your pad, one thing that I'm hoping by now that you're all doing is you should be pre-soaking your pads. So a nice piece of plastic Tupperware where you can take 2 or 3 of those pads and keep them submerged in oil so that when you do go to put those pads in, they're already softened up and they're already saturated with oil. There's 2 reasons to do that. One is to soften up those rough burnt embers that are on there. The other reason is that it's going to absorb a certain amount of oil and it isn't going to do it immediately. So if you put dry pads in there and then you just fill the sump with oil to where you believe is the proper level, by the time it soaks it in there, sometimes you're running shallow and don't realize you're running shallow. The replenishment is not strong enough to really ever recover you from that. So that sometimes is also where you will see that dry ink building up on your metering roller and or donor roller. So what I really suggest is that when you do put your sump in after replacing your pad and your blade and whatever maintenance you may be doing, is when you should definitely add oil to that. And it's set to drain. And if you look over on the left-hand side, when it's clipped into position, which is another thing I've noticed, please make sure that your sump is clipping behind the clip and going behind the clip easily and not a struggle, that you don't have to lift it up and pull it down and that it's going in that proper position. But if you look to the left of the sump, there's a little clip there, and that little clip, once it's clipped into position, that little clip will open up and it will drain whatever excess oil is in the sump out. Better that it be overfilled and you look over to the left, and as you look to the left, you will see that oil coming out of that spot. Just let it come out until you see a slow drip, and then you're where the oil wants to be and needs to be. That's the best way that I can say to make sure that when you pull that sump out and you do that kind of maintenance to it, to make sure that when you put the sump back in, that the oil is exactly where it needs to be. And if you want to chime in on that, Rickey, and add anything I might have forgotten.
Yeah, that's a good point. You don't want to be underfilled in that sump, and you want to give it time to drain off, because if you manually put fluid in and it resides on top of that blade, what actually happens is that it sends out a surge of fluid as the metering roller picks that fluid up from that blade surface. That will get applied to your fuser roller, and if you're running like thin substrates, that fluid that's on that roller during that surge will cause that sheet to stick and not release properly. So as Mike stated, you want to, fill it up, let it drain back, through the system. Keep an eye on it and make sure that the fluid has stopped flowing from that little trough in the back as that relief tab opens up to allow it to flow out. Make sure that that's stopped, and in that case, you're in a good position, so you're not going to have this surge of fluid coming out to give you issues with paper handling on your fuser roller surface.
Okay. Rickey, do you want to address those two questions?
Yeah, let's see if we can take this first one here. I see the 16-point stock. That's a coated C2S substrate. Look like the toner is scratching off. It's a long sheet. Let's see, what's the size of that sheet there? 14 by 26. Now, remember the 26-inch paper, in some cases I've seen that where we have a buckle assembly that's sometimes needed in order to take that buckle out of that sheet as it goes into the fuser nib. Some cases it could be speed related, which indicates that your VT and your fuser roller surface speeds are not set up correctly, meaning that your VT speed is probably running faster than your fuser roller speed, so you're getting a real aggressive buckle as that sheet goes into that nip area. The way the system should be pulling the paper from one element to the other one. So the VT should pull it from the ATW, and then your fuser roller speed should be slightly faster than your VT, pulling it from the VT to take away some of that aggressive buckle. So if you're seeing that buckling issue, you may want to get an FE in there to first check your speeds, because that may eliminate your buckle. If that doesn't work and you set those speeds up, then there is a buckle assembly that you could order in order to take the buckle out of the system. As far as the toner scratching off this thick substrate, I've seen where if the substrate thickness coupled with real heavy laydown inks on the substrate, you may need a little bit more energy in that sheet. So as a diagnostic that I just shared with you would drive you to do, if you would just increase your temperature by 3 degrees and your energy flow by 30 watts, reprint that run, you should see where that ink is scratching off less. And then you find that sweet spot for that job and then lock it in at those set points. Question 2, basis weight, which is a difficult one. Pretty much that's the 500, taking 500 sheets from a ream that's of a certain size, and then it'll pick the size based upon the substrate type. And then it would actually give you how much that ream of paper would weigh. The quickest way for me to handle the basis weight question is to go right to your website and type in basis weight calculator, and it'll bring up a box, and then you'll be able to enter your GSM value, and it allows you to pick the substrate type, and then based upon the substrate type, it will pick the size that's automated in the system and put it in a table, and then if you click calculate, it'll give you the actual basis weight. For instance, I took one 75 GSM paper, and when there's a drop-down selection in this calculator that you're going to see. You click that and click bond paper, and then it'll put the size of the paper that has already been determined by this calculator. And then you click the button that says calculate, and it'll come back and tell you that the basis weight is 20 pounds. So use that table in order to determine the weight of the substrate if that's of interest to you. Once you put that in to your category, it's going to set the GSM value, which is what we use in the system to really set temperatures and energy flows. So the grams per square meter is a more important parameter as far as setting up the job than the basis weight. But that's just a quick way.
You really don't, you don't really need basis weight. You can base everything you're doing off of the GSM. Yeah. And most digital papers that you're buying today that are coming pre-cut 12 by 18, 13, 19, 14, 20, all have the GSM written on the label. So the 100-pound cover is going to be roughly in that 270 GSM ratio. 100-pound text gloss text is going to be around 148. That should all be listed there. I usually stay away from the basis weight because it is an average. Yep. Although since it isn't a caliper weight sheet, whereas you're dealing with the 16 point, every single sheet must mic to 16 point, which since it is that grade, whereas the basis weight doesn't have to do that. But I think if you just use your paper settings and use the GSM, you'll be better off than worrying about the basis weight. And I think, unless Ricky wants to add anything, I think we'll open up to see if anybody has any questions for either one of us.
Yeah, I don't have any questions online, just so you guys know. I don't have anything in the Q&A or the chat. So I'm going to go ahead and open up the phones, although if people have a question and they prefer to type it, I will monitor the Q&A chat areas as well. Of course, as soon as I said that, one popped up in chat, so hold on a second. All right. I'm having issues with the inks rubbing off with the HD inks. The inks will not scratch off, but they will rub off. If I take a sheet and rub it against another sheet, the inks rub off easily. Don Capinis sent some sheets to Ricky Stevens Friday. The FE was helping with the settings, but with no luck. It has happened on multiple substrates, weights, and thicknesses. Okay.
So I guess samples are coming to me. I will be getting those, and I'll analyze them. I'll look at them, get some detail, and get back to his FE to see what the issue is, if we can do anything from a fusing standpoint. There's a couple of options that you can use here. I don't know what version of software that's on their machine, but if they're operating with software, I believe it's 15.2 RC17 or higher, there should
16.
be.
They're running System 16.
Okay, so there should be a selection that says Duracoat. So right now we use like a Duracoat, and what that does, it puts a small amount of clear over your inked areas, and then that protects it as it goes through the milling system and against this rub-off that he's experiencing. We're also, looking at some wax additive dry inks at this point, and so we're doing some studies around that, and if they become available, then that will be a secondary option.
I want to make a comment about this. Whether everybody is experiencing this. The HD inks, to a certain extent, will, if under pressure, will do exactly what you're saying it's doing. If yours is extreme, then it may be something that Ricky's going to need to get those sheets and take a look at. But a couple of the things that I would suggest on jobs, rarely are we rubbing the sheets together. Where people are noticing it is when you pull yourself off the main delivery and you are not lifting and you're dragging the sheets, the bottom sheet that is still there is getting scuffed. That's one area. Yes, if you take one sheet and it has heavy ink coverage and lay it down over another sheet and apply a good amount of pressure and rub it, it will do that. And so it isn't too often that you're taking sheets and rubbing them together like that. I usually say that if you lift the sheets out of the main delivery rather than drag them, you will. That's one area where you're seeing it happen. In most cases, going through normal bindery of cutting and scoring and folding, I have not seen that rub off to be a big issue. Where I have seen it is occasionally on business cards where you have something like a solid blue on the back and on the front of the card, it's white, and they are occasionally going to do that. And that is where I would highly recommend what Rickey's saying with the Duracoat, running the clear station and running the Duracoat, and that will eliminate that. One of the reasons why I don't push the Duracoat too much is because if you're using the Duracoat, then you're not using the white black or one of the other stations you may need to use there. So something to think about there. If what you're seeing is excessive, or whether or not it's that now that you've noticed it, you're taking these sheets and you're rubbing them together and you're seeing the ink come off. It is, that HD ink is prone to a little bit of scuffing. So it's something that, you know, there are some workarounds for, but that would just be something that I would mention, that if they're not being dragged across one another, you're really rarely going to see that.
So I do have a couple of questions, and this next one, Greg, I'm going to ask you just to respond to because I think it's an out-of-spec question, but it is something that we did notice in the forum. There is an operator that's having difficulty running a 15.7 mil synthetic stock. They're having the issue of blue turning into pink strands. They did get the response back in the forum that right now the next press does not handle above 8 mil in synthetic. This operator is actually also running dimensional on that same job. They tried testing it with yellow and other toner, but the dimensional was flaking off. Any suggestions on what they might be able to do with this?
Yeah, I'll make a couple of comments, and then Rickey and Mike might have some. Yeah, the current specification is 8 mil, but that 8 mil on synthetic is dependent on the material itself. The thicker specification up to 8 mils is on a polyester material. Polyester, PET, you would say typically. Some of the other plastics like PVC and polypropylene have a thinner weight. They do have a lower melt point and do cause some issues. The more insulating materials sometimes cause less problems or more problems depending on the coating. So, you know, once you move outside of paper into synthetics, the variation in coatings and performance can be very wide. So going back to the question that was specifically asked in the chat, 15.7 mil is nearly double the current spec, and that's for the widest or thickest spec on polyester. Adding DMCL also causes a higher heat to be required, and that then has a further impact on the range of synthetics that can be used. With the substrate expansion kit that we announced last year and are working to make available later this year, we will widen the specifications. Again, that will make the polyester go up to 14 point based on our current testing, 14 mils in our current testing, PVC a little over 12, and polypropylene at a little over 9. That's based on current testing. We have to validate that in the field. But none of those go up to the 15.7 mil that Chris lists here in his message. So the press just simply is not capable of supporting that with great results. Now, you will certainly find examples of materials, well-structured materials with specific coatings that can work for certain applications, but generally that thick of material does tend to cause too many problems in the machine. Rickey or Mike, do you have anything to add on handling DMCL with synthetics that are within spec?
I think you've covered it, quite nicely there. We do increase the temperature, like you state, for DMCL. That could be doing something to the hue of this synthetic. Guess we would have to, perhaps see some, samples of it if we want to look into it. But as you stated, it's clearly out of spec.
And I'll make a quick comment as well, is that there's a couple things here that are like the trifecta of problems here. The excessive weight, the dimensional clear, and the color are all in combination of making this really, really next to impossible to pull off. The synthetics are difficult as they are staying within spec, but the one thing that I would just bring to your attention, especially if you're on the forum and people are suggesting that you increase the transfer current, to be very careful with that, because if you're going to probably not notice. I would never bring your transfer current up higher than a maximum of 30. That would be, even though it says 55, you got to be really careful, really banging up that transfer current. You could blow a power supply and you're down, and you can cause yourself a lot of other problems, because what starts to happen when you start raising that transfer current up is you start to alleviate one problem and create another, because you're going to get a different anomaly by bringing that transfer current way up. And on that 15.7 mil, even bringing it to 30 isn't going to make any difference at all. There are times when I tell people that your transfer current is definitely, you should bring it up, like the question where you were talking about the 16 point, the 14 by 26 16 point, sometimes you can get some cross-track banding, and because of the ink coverage and the size of that sheet and the thickness of that sheet, and taking your transfer current up maybe to a 25 or 28 may alleviate that cross-track banding, the banding that's going in the short direction of the paper. And that's one instance where you may want to mess with the transfer current. But in this particular case, I think messing with the transfer current, if you're going to continue to try to run a 15.7, which I would highly discourage you from doing it, it's probably not going to work the way you want it to.
Okay, I have one more question. On a heavy 15-point stock coated one side, is it possible to have two different temperature settings built into the stock? The coated side looks great, but the uncoated side usually tracks down the sheet.
Okay, I will start out on that one. The rule of thumb for that is if you're running C1S stock, you're putting on the coated side, then you can run at the higher temperature settings. That temperature is usually like a 170-degree temperature. But then if you print on the second side, right, which is uncoated, now you pull that ink from that side because your temperature is too hot for the uncoated. So what you need to do if you're going to print on both sides of a C1S stock, you need to bias your set points to the uncoated substrate set point. That way you can fuse on both sides because you can't have two different set points. You have to bias your uncoated side first, and then your coated side will print good at those set points as well.
So then I'm going to chime in now also and say that you should have two substrates for every C1S you have in your system. You should have one that's for a 15-point C1S printing both sides, and one that's a 15-point C1S single-sided, and calibrate both stocks, the C1S single-sided and the C1S double-sided, so that you are not running the same exact settings and the same exact stick on both the single-sided C1S and the double-sided C1S.
Okay, I have one more question. Does the speed that a job is running have any effect on fusing properties? Big differences between slow and fast speed. Do you need to change fuser settings depending on the speed?
No, you do not. Software does that automatically. So what we do, we bump the temperatures on the hood, which is the customer doesn't see it. But if you run an 83 page per minute machine, your fuser is going to be running 5 degrees hotter than what's in that substrate, because we're balancing out the shorter dwell time that's occurring in the nip. If we increase our speed to 100 pages per minute, then that bump becomes 10 degrees. And if we're running 120, that bump becomes 15. So the temperature bumps are occurring under the hood. You shouldn't have to make any adjustments in that substrate because it's done for you automatically. The only time you would have to adjust those substrates is if your toner stack is a little bit too high. If you're getting offset like we're talking here, then you might want to tweak those settings based upon that. but the first general bump is going to occur for you that's happening through the software.
Okay, I don't have any more questions online, so what I'm going to do is go ahead and open up the phones. Before I do that, I'm just going to remind everybody to please put their phone on mute or *6 if you're not speaking. That'll just help cut down the background noise. We are recording today's session, and I will share this with you. Our next session, since this was Part A, Part B is going to be reviewing the actual adjustments that you can make for substrates once you've identified some of the warning signs and diagnostics that we've gone through here today. So thank you again for joining, and I will take you off mute, but again, please put your phone on mute or *6 if you are not speaking. Thank you.
All guests have been unmuted.
Okay, the lines are now open. You feel free to ask your question live of Ricky or Greg or Mike. I'll also continue to monitor in case you want to put it in chat or Q&A. I'm not seeing any extra questions here. All right, I guess we'll wrap up a couple minutes early then. I want to thank everybody for participating. We will send out the link to YouTube, and I'll also send out a PDF of the presentation for the content that was shared today. And our Part B session, going through substrate adjustments, will be on April 3rd. Thank you, everyone, for attending. Mike and Ricky, thanks for presenting, and Greg, thanks for jumping in on the questions.
Thank you.
Well,
Bye.
bye.